So when you have to set up a loop, my advice was to start at the test, okay? Which is not the beginning of the loop, but it's sort of what, by looking at the problem, it's easy to figure out what the test is. Now, the particular type of loop that we looked at on Tuesday was something called a sentinel loop. So I'm going to give an example of a sentinel loop to start with, okay? So this would allow us to enter a lot of data, a lot meaning millions of entries, or a little data, meaning 1 or 2 entries, okay? And that's determined by whatever the user decides to enter. So let's say that we decide we're going to enter numbers and print whether they're odd or even, okay? So the user can enter integer values, and we want to have some ending condition, and I'm going to choose a sentinel of, let's say, -1, okay? So if I set up a sentinel loop, that tells you, remember I'm telling you these little ding-dings, you don't, like, once you understand it, you know I'm trying to give you the tools, so when you get a problem, you can very quickly set up the framework of the solution, okay? So if you get a problem that says read numbers, you know, quitting on -9, or -1, this says to me, okay, I need a sentinel. So the part 2 of the sentinel, the test part of the sentinel, of course, has the while. And I'm going to go ahead and define the number, just an integer number that you're going to input. So what is my sentinel condition? So you're quitting on -1. So what's... Okay, now if I say equals... Now I'm going to go ahead and write that, because if it says equals -1, that means that this will loop while it's a -1. So in fact, I want the inverse. I want the not equal. And this is tricky because it's sort of the double, you know, the backwards negative idea. But the idea here is that and it's not num1. While num is not equal to -1, so any number besides -1 will enter the while loop. Does everybody see that? Okay? So for a couple of semesters, I always called this step 2. But I always like, you know, things that are, I don't know, have a ring to it. So I started with this star thing, okay? And I don't know, whichever helps you. I don't care, whatever helps you. So step 2, we remember, is also the test part. So this is where you start with the while loop, okay? Step 2 or the test part, whichever helps you. I don't care which one you use. Now, in order to get this loop started, I need to prime the loop, okay? And I could do this, but this would kind of be cheating. Because if I'm going to do this, isn't that essentially going to force me through the loop? So why in the world would I use a while loop? If I'm going to do this, then use a do while, okay? But the whole reason I chose the while loop was, wait a second, I forget. Why did I choose the while loop? So I can get out. So if the user inadvertently gets in this program and wants to be able to exit right away, they are forced to the loop. They don't have to go through the loop at all. So I do not like this way of starting a while loop at all. I find this a wrong use of a while loop, okay? So instead, we're not going to set this to 0. Instead, we're going to ask the user to enter the first value. So everybody knows how to do that because, you know, these are steps you know well. And I'm going to call, just via comment, you don't have to do these, but I advise you to initially. I'm going to call this step 1, which is the start step. And there's actually 2 lines to the start step because I need to both ask for and get the value that will start this loop. Okay, there are questions so far. So I started with step 2. I set up based on the problem. I decided what the framework of my loop was. And I started with this while num's not equal to -1. This is a sentinel loop. Basically, it's going to enter numbers till -1. Okay? So then I prime the loop with my step 1, which gets the first number. And now I'm going to set up my loop. So the loop is going to differ depending upon what the problem asks for. So this particular problem asked me to print whether the number is even or odd. So what do I use to print whether a number is even or odd? Modulus. So here, this is nothing new. This is just using our knowledge from before, right? We say if num modulus 2 equals 0, then we can say that it's even. Otherwise, we're going to say that it's odd. Now, all these steps here really make up the body of the loop. This is all what we call, I call either step 3 or the action. And this, of course, is going to differ based on the problem. So the loop's going to look similar, but whatever's in step 3 is going to be depending upon what the problem asks for. Okay, so that's going to differ widely. Okay? So this then will enter the loop if what? It's not a negative 1, okay? It's going to print whether it's odd or even, and now I need to, if I stop the loop now, let's actually run it. And the other thing is I've been yelling at everybody, not yelling, speaking in a very friendly fashion, about the indentation. You know, I'm really annoyed. Indentation is so important with these loops. Do you see how this shows me the logic? I don't even want to look at your code if your indentation is not good. The indentation is not there because, you know, I'm an annoying person, which may still be true. The indentation is there in order to help you figure out the logic of the program. It means something. So notice that as soon as my logic is conditional, I go in a tab. So in the case of the while, I tab in because I may not get to that code. In the if case, as soon as my logic is conditional, I go in a tab. So it's very defined indentation. And the brackets should line up so you can tell clearly what's happening. As your logic gets more complex, the indentation is more important. Okay, does that make sense? Okay, so this program is wrong right now, but let's run it. So it asked me for a number, and I'm going to enter a number 4. Now what in the heck? What's going on? Jeremy? Restart. I didn't have a restart step. Exactly. So what is the scenario there? I mean, let's look again. What do we call this situation? Can everybody see what's happening? Even is scrolling up the screen. What do we call that? This is called an infinite loop. How many people saw an infinite loop the other day? Okay. You will see an infinite loop, okay? Generally not on purpose, okay? So the reason is, let's follow the logic here. So there's no magic, okay? The computer's stupid, all right? It does exactly what you tell it. So when I got to this line right here, actually I put it an extra space, which I really didn't need. It printed enter a number, of course. I entered the number. It got right here, okay? The number was not equal to -1, so it came down here, and it printed even, okay? Now, it skips the else, and it comes down to this bracket, and what happens when I get to this bracket? It comes back up to the test part, and it checks to see if num is equal to -1. Well, what is num right now? Still 4. It's still the first number I entered. So it's going to say even, is num not equal to 4, true, even. So do you understand what was happening there? Does everybody see why that was an infinite loop? Ask me if you don't. Don't pretend you know. Yeah, thank you. So what it's doing is this happened once. This happened next. Okay? This happened following that. That's why we got the even. It finished the loop and came here. Whenever you get to the, not finished, wrong word. It went to the bottom of the loop, and it always returns to this test. Num has not changed because I have not entered another value. So it remains at the 4 that I entered. Okay? So it checks to see if 4 is not equal to -1, which of course it's not. And it comes down and it prints even again. And in fact, we'll do this a million times. This is an infinite loop. There's nothing to stop this loop from, okay? Because it took the initial 4 and it keeps going through that loop. Okay? So what I need is, so notice that I have step 1, step 2, step 3. This is all the action. I need that step 4. The good news about a while loop is a lot of times step 4 looks like step 1. So I'm going to ask this time for another number, that's all, but we're going to call this step 4 restart. So this asks for the next number. So after it prints even, it comes down here, asks for the number, and then it takes that new number up to the test. Let's run it. So I enter a 4. It tells me even. I enter an 8. I enter 280. Let's give it an odd. It's odd. I can keep going forever. Okay, that's the advantage. That's why I said this is a grown-up program. Okay, because this program will keep going until I decide to get out. Okay, and then if I enter -1, it fails the test, comes up here with a -1, and it say -1 not equal to -1, false. It's that double negative. I know it's a little tricky. And then it gets out. So there's no magic to this loop. It's a stupid thing going here, making the test here, either doing this or this, doing this, coming back up and doing this. Okay? Does that make sense? There's no prints that happen unless you put them in there. There's nothing that happens unless you tell the loop to do that. Okay? Is this making more sense with the while loop? Because I feel like everybody felt like it was a little magical yesterday, and there's no magic to this while loop. The for loop's a little more magical. The while loop is just down and dirty. It does exactly what you tell it to do. So if you set it up using this 1, 2, 3, 4 framework or this STAR framework, then whatever here's where this is where everything's really going to change. So if I tell you to print positive or negative, if I tell you to count numbers, if I tell you to, let's say this time, rather than printing odd or even, I'd like to count the number of odd or even, which is a lot more useful. How would I go about counting the number of odd or even numbers entered? Tyler? I need 2 new variables, and what do we call those? Ding, ding. Counter. I'm going to call, yeah, okay. I'm going to call them odd counter and even counter. But the 2 new types of variables I need are counters. Anytime a problem asks you how many, you say, ding, ding, I need a counter, right? And the 2 steps for a counter you're going to help me with. So I'm going to, of course, you always declare. Obviously, I'm not saying that anymore, right? You always, any variable you need, you declare. Why is the counter of type integer? Why is the counter of type integer? Because it's whole number. I'm not going to get 2 1/2 even numbers. I'm going to get a specific number, right? Okay, so here's my counters. So what are the 2 steps I do to a counter? Who can remember? Brianna? I have to initialize it to 0. I can do that here. I could have done it as a separate step down here. So the important part is that where should I initialize the counter? Before, during, or after the loop? Before the loop. Does that make sense? I need to start with the value 0 when I count. Because the computer will not, some languages initialize to 0, not C++ by default. Do you understand? You cannot count on the language initializing to 0 for you. What's in a value when I start? Garbage. Who knows is the answer. Okay? So the same thing happens to odd counter. Okay. So that's one of the things. Whenever you need a counter, that's what you tell yourself. I need to initialize it to 0. What's the second thing I need to do to a counter? Who remembers? I think somebody said it. What's the second thing I do to a counter? Come on, somebody else. I need to increment, right? So, right, if I give you a bunch of numbers, okay, 100, 150, 95, 36, what am I doing each time? I'm bumping my count, right? I'm bumping my count. So where should I do that then? In this action step, in the action step. So what I'm going to do here, I'm going to go ahead and keep printing even, but I'm going to bump the counter here. So why did I put brackets around the code there? Thank you. It's a compound statement. Nothing goes away in this class. Every single thing we say comes back and we use it soon. Do you see that? These are all tools. Does everybody understand the steps that I just did? Okay? So if the number is even, not only am I going to print even, but I'm also going to bump the counter. Everybody with me on that? Okay? And then I also need to do the same thing for odd, which of course is easy. Also make this a compound statement. Bump the odd counter. It's like 100 degrees in here. Okay, now where should I print the counters? Where should I print the counters? Outside the loop. Why? Make sure you understand this. Why do I print the counters outside the loop? Kayla. Yeah, I mean, typically, I don't want to have a count every. I mean, if the problem asks for a running count or running total, knock yourself out and add it to the code. But first of all, it's inefficient. It's sort of like, who wants to see it on your screen? And anything added to the loop starts to add up in terms of cost. Okay? So typically, if I'm counting, I don't care how many you've got along the way. I want to know your final count. So typically, the prints would happen after the loop. Does that make sense? So this is after the loop. So here I would say the number of even numbers is of course, this is something everybody knows how to do now, and I'm going to do the same thing for the number of odds. Are there any questions about anything I'm doing so far? Does this make sense? Okay. So now I enter numbers till I'm blue in the face. What did I do? Oh, yeah, thank you. Okay, I just copied and pasted and didn't. I still did it wrong? Did I have something wrong? Odd, even. Okay, so I'm going to enter, let's just do things like this. Oh, I didn't do that on purpose, but so I got 5 even and 5 odd. So it counted for me. And so now that I have this loop, I have a lot of things that I can do, a lot more things I can do to the data. Yes? Well, that's what I counted. So if the number was even, that I've said I'm keeping track of that. If the number's odd, I'm also keeping track. So I had a counter for each one. I can count whatever I want to. Whatever, right? I may count the number of numbers above 100. I may count the number, whatever. It's whatever I say it's going to do. Yeah, so a counter is useful for a lot of things, okay? Now, what about if I enter a -5 for this program? It's still going to enter. So possibly or wait a second, can negative numbers, let's see what it does. Are they even and odd? I guess. Let's do -2. Okay, so it still works for negative. What about if I want to change this program so it doesn't accept any negatives? What could I do about that? Tyler? Yeah. So it's not always a pure sentinel. It could be some condition that so this loop is going to continue to loop so long as 0 or anything else is entered.